The biggest blunder to date was NASA's DART mission. And then I want you to notice as you were zooming in here, that it's a rock pile. And the closer you get, the more you see it's a rock pile. And if you've had courses in orbital physics, to think about how it's even possible, it's impossible for rocks and dust and dirt of various sizes to come together in space. It's impossible without an environment of molecules of air to slow it down. So they're getting all excited here, and we're going to get in and see, I think, this last frame. What does that look like? It looks like that is, ladies and gentlemen, that is Earth from 5,000 years ago put into space. That's what it is. And just like the Temple 1, which was years earlier, just like Temple 1, they can't find, they sent a probe to watch the impact, to see what the crater did, and it blinded that probe, so it made it unable, they don't know what happened because the same blinding happened. They repeated their ignorance of what comets and asteroids were made out of. In 2016, 6 years before impact, I wrote the physics behind a chosen plan to work for one composition of deflecting an asteroid, solid rock, but will fail if the asteroid consists of loosely held together rock pile. And then after the DART mission hit, after the day that I saw it, since DART confirmed what all HPT advocates suspected would be the case, that it's a rock pile, I thought I should take a stab at predicting what the IKEA cube cameras will show, which is a big flash, and that would cause a meteor shower, that this stuff could come and impact the Earth, even though they had promised us that this mission would have no detriment to the Earth. This is what was found when it hit. This is what the IKEA cube saw, exactly like Temple 1. Blinded the screen. They should have known that what should have happened is they should have put that camera that was following the impact, they should have put it back several days from what they learned on Temple 1. They should have had it come days and days later. But instead, it got blinded. The camera was useless. This is what was seen by Earth-based telescopes when the collision occurred. This right here is the Didymus Dimorphos asteroid. And it hits, and this is the debris field that is being ejected into space, into their orbits around the sun. And this is the comet. It left a comet tail. It left this tail of debris that showed light for days and days and days. And so then NASA came clean with the fact that the NASA asteroid deflection test accidentally creates a boulder swarm that could impact the Earth. It turns out, years later, or many, many months later, they did a computer analysis of all the debris, and it turns out that in the next several thousand years, there's not a single chance of any of that debris hitting Earth. The collision shortened the moonlet's orbit by 32 minutes, surpassing the 73 seconds, and significantly changed the asteroid's shape. The DART mission's unexpected findings served as a powerful reminder of the complex and interconnected nature of our solar system. We must remain vigilant in monitoring the consequences of our actions, the blunders of our actions, of having the wrong idea of what we're doing when we go up into space, hitting things. The reshaping of Dimorphos is completely outside of the realm of physics as we understand it, said Christina Thomas. And when I read that, I thought, it's not completely outside of the realm of physics as we understand it. That's exactly what would happen to an asteroid if you smacked it and it was made out of a bunch of rocks that were all loosely held together. You have to have the right perspective of the past of what made these things if you're going to have a redirection test. The European Space Agency cannot explain how a very loose internal structure similar to a pile of rubble that is held together by gravitational interactions and small cohesive forces. They know that's what it is, but they can't explain how it got there, how that happened.